Alright, hi year 11, this is Mr. Lim here again, and this is our video on precipitation reactions in aqueous solutions. So let's go. Okay, so we're going to be learning some stuff. Okay, so let's have a look. Ionic solids, ionic solids can have varying solubilities depending on the type of ionic solid. So for each ionic solid, you have to check if it's soluble or not. So certain combinations of cations and anions are insoluble, while other combinations are soluble. So we're going to check every single time. All right, so on your data sheets, there's this solubility rules for ionic solids and water somewhere in the middle of your data sheet. All right, so you have to find that yourself. You should go get one now and open it up. So what we're looking for is that this section here has been split into two. It's split into soluble in water and one table here, and then insoluble in water and one table in here. All right, so what it shows is that on the side that there is the anion, right? The anions here, and that's how they've sorted them out. And then we have to use whichever table it's in to work out whether it's soluble or insoluble. So let's go through a couple of examples. Okay, so over on this side over here, we're looking at sodium bromide. Okay, so we are looking at the anion, and the anion here is bromide. So we look for the bromide anion in either of those two tables, and we find the bromide ion here, the bromide anion there. Okay, so that bromide ion is there. It is in the soluble in water table. So if it's in the soluble in water table, that means that most things with bromide are going to be soluble, right? Then there are exceptions to the rule, which would be silver bromide and lead bromide. Since sodium bromide is not either of those things, it's not an exception to the rule. It is not an exception to the rule if it's not in the exceptions, which means that it is going to be whatever table it's in, which is soluble. So we can say that this one is soluble. Okay, all right, so let's go to the next one. Okay, the next one, lithium hydroxide. So we would look, so hydroxide is our anion. So we find the hydroxide in one of these two tables, and we find the hydroxide here. All right, so most hydroxides are insoluble except for these ones here. Right, so we say that, okay, then is lithium hydroxide is generally going to be insoluble unless it's in one of these, and lithium is not there, so this one is going to be insoluble. All right, so let's go to the next one, calcium chloride. So we're looking at the anion, the chloride. We look in the table, we find the chloride here. They're in the soluble table. So most chlorides are soluble except unless it's an exception. So we check calcium, is it an exception? No. So therefore it is soluble because it's in the soluble table and it's not an exception. Let's have a look at the next one. Lead sulfate. So we look at the sulfate part, the anion. The sulfate anion here, it's here. And then we look if lead is an exception. So we look here, look, lead sulfate is an exception. And so because it's an exception, it's not going to be soluble, it's actually going to be insoluble. So because it's an exception to the rule, it is insoluble. Let's have a look at the next one. Potassium carbonate. Okay, so carbonate here. We look over here and we see that the carbonates are here. Right, the carbonates are here. So we look at that's generally going to be insoluble, but then we look if it's an exception. So we look at potassium. So carbonates, is potassium an exception? Yes, it is. Potassium carbonate there is an exception. So it's an exception to the rule. So it's going to be, what does it say? So potassium carbonate is going to be soluble. So that one is soluble. Right, copper 2 phosphate. So we look at phosphate, the anion phosphate is here. It's mostly insoluble unless it's an exception. So we check copper. Copper, is it there? No, it is not. So therefore, it is going to be insoluble, not an exception to the rule. So insoluble. Right, chromium 3 sulfide. Right, so we find sulfide. Where is it? Sulfide is here. Right, is chromium an exception? Nope, no it is not. So therefore it is insoluble. Right, and then we finally look at the next one, silver iodide. So silver iodide, right? So iodide here, we look for it here. Here it is. Most iodides are soluble. We check if it's an exception. So we check for silver. Okay, silver is Ag, so yes it is. So it is insoluble. Right. Okay, so part of this table here is this slightly soluble part here. Right. Now, if you find yourself with a substance which is slightly soluble, we have to look at the concentration, which we will deal with in another video. But if the concentration is higher than 0.1 moles per liter, if the concentration, I'll write that down, concentration is greater than 0.1 mole per liter, which is really not a very high concentration, then it's going to be insoluble. If it's less, then it's going to be soluble. All right? So if concentration is greater than 0.1 mole per liter, it's insoluble. If it's less than that, it's soluble. Okay? Let's have a look at the next slide. Okay, so let's go through. If two ionic solutions are mixed together, they will introduce a new combination of cations and anions, some of which may be insoluble. Okay, so you've got two solutions, effectively 4 ions, 2 positives and 2 negatives. They're separate from each other, and then you put them together, you will mix those positive and negatives and you'll make new combinations. So if these new combinations are insoluble, they will come together and form an ionic solid within the mixture, known as that precipitation reaction. So you will literally have a solid form when those two solutions are mixed. All right, so let's have a look here. We have lead nitrate and sodium sulfate. Okay, we have those through 4 ions. Okay, we have 2 positives, these 2 here, and these 2 negatives here, the 2 cations and 2 anions. So this is already one combination, and this is already one combination. But when you mix them 2 together, you're going to have new combinations. You're going to have the positive from this one go with the negative with that one, and positive from that one and go to the negative with that one. So you're going to have lead sulfate and sodium nitrate. Okay, so using that, we can go check this again. So lead sulfate, so we go find sulfates, and sulfates are here. It's lead, and it's lead 2. So lead 2 sulfate, okay, it's an exception, so therefore it is insoluble. Insoluble, this is going to form a precipitate, which can be shortened to PPT, right? That's the word that we use to describe insoluble substances, right, within that solutions that come together, right? Sodium nitrate, we're going to check that one out. So nitrate, soluble, yep, there it is, all nitrates. Now it's all nitrates, so there's no exceptions to that rule, so that's going to be soluble. Okay, so let's have a look at the next one here. So we've got sodium chloride, silver nitrate. Okay, so we got 4 things there. We're going to go look at the different combinations again. So we're going to have the combination of sodium nitrate and silver chloride. So sodium nitrate and silver chloride. Okay, we just did sodium nitrate, so that one is soluble. So now we're going to look at silver chloride. So we're going to look at the chloride, the anion. So chloride is, oh, here it is, most chlorides. And then we check the silver. Is it an exception? Yes, it is. That's insoluble. So therefore, if that is insoluble, that's going to form a precipitate. All right, then the last one, copper, nitrate, sodium, sulfate. Okay, and so you see here again, you're going to have sodium nitrate, which we've already done already, which is going to be soluble. Right, and then we've got copper sulfate. Copper sulfate, we check sulfates. Sulfates are up, Here we go, soluble. In the soluble table, we check if copper is an exception. Copper is not an exception, so therefore this is soluble. So this one is not going to form a precipitate. It's just going to have the two mixtures mix and not have a reaction. So this is just going to be a no reaction or no precipitate is formed. Okay, and precipitations can be useful. This type of reaction can be useful to remove certain ions from solution or identify if they are present. Okay, so if you want to find out if you have lead ions, you might be able to do so by putting it with something that will precipitate with lead ions. Okay, so precipitate with lead ions, right? We know that lead will precipitate with a whole bunch of stuff. It's like this one here, because we know that's insoluble, that one there, and any of these, because lead is not an exception there. All right, so because lead is not an exception there, we can use one of those, or we can use one of the ones, the iodide or the sulfates. So if we were to try and remove lead ions, we would add some sodium iodide, because sodium is soluble with everything. So we could add some sodium iodide solution, and the iodide would mix with the lead to make PbI2, and then you'd be able to see that precipitate come out. All right. If you copper ions, you can add in any of the insoluble table there. So you can add in hydroxides, you can add in carbonates, you can add in phosphates, things like that. Okay, and then the same with the magnesium and the aluminium ions. All right, so that's that. Adios.